Okay, so I have my pan right here. So again, normally we'd use the front drill and just drill through both of these walls. But instead, let's try and do it from the top drill coming down. So what we want to do is first figure out how much we want to mill out. So I've had the best success making a 3/4 of an inch slot. And then I'll move this guy, center it up in between, right over here. And that'll be enough to clean out this. Actually, let's go a little bit smaller. I don't want to go too far in. Let's go 11/16. Okay, so that's how long my slot's gonna be.
11/16.
Yes, yep.
This is 11/16 slot, right?
Alright, so let's go into Clear Studio, let's start building this out, and we'll figure out our dimensions and everything else that we need. So Clear Studio, to add fabs, there's two types of fabs. There's primary fabrications and secondary. Primary fabrication is part of fabrication that goes directly on the part itself. So like your cover, your pressure bar, your weep holes on your pan, and your horizontal concealed fastener holes, those countersunk holes. Those are all primary that go directly on that part. Secondaries are, like say down the road you're looking at your jam and you notice that the holes are off like on the heads. Well, you don't look at the actual jam part number to try and fix those holes. You're actually going to look at that head member and look at its secondary fabs that it's spitting over onto that main member that it runs into. Alright, those holes generate from either a shear block or from screw spline holes that come from that part. So I investigate the head member. So that would be a secondary fab on the head part number versus a primary would be directly on the part itself. Like a weep it just goes directly on this part. So we're gonna mess with the primary fabrication rules. I'm gonna pretend this is not here. Okay, so starting with, it looks like a lot, but really once you break it down, it's not too much. So fab style, whether we're in a screw spline or shear block system, when we're using this part. So we're gonna choose screw spline, and then glazing style. Now whether it's inside set or outside set, we're gonna choose all. That way in case our conditions change down the road, we don't have to make another one for outside or inside. Same with stop position. Whether you typically use stops down or stops up, let's just choose all. Covers all our bases. And then operation. So on that machine, there's a long list of these things that you can do, but the 5 typical ones that you can access that will do everything are going to be circle, countersink, drill, rectangle, and slot. So for this one, we're going to choose slot. Slot is when you either do a mill in one direction, either down the width of the material or across the height of the material. But it's only either or. So for slot, that's going to be our selection. And then X location. So X location on the part. So when this part's on the machine, X is from the back of the part, which is when it's facing inside the machine, it's going to be like this. Okay, this yellow kind of represents the back of the machine, where it's facing away. And then you essentially have like a basically have like this is where your back drill would be going in to mill, right? So if we can picture it that way, our X location is from the back of the part to the front. Our Y is from, it's hard to picture, but if this stick kept running down long ways, Y is down the length of the part, and Z is always from the bottom of the part going up. So that's our Z. So if we're looking for our X location right now it's not a lock position. It sounds misleading, but it's just saying what's the X location. So everything works off center points, whether you have a drilled hole, whether you're milling a circle, whether you're doing a rectangle, you're working off center points, and then when you give it the height or width of that shape, the overall size, it moves in both directions equally. It divides, say you wanted to create like an inch circle in diameter. Well, it moves ½ inch that way, ½ inch that way. Same with the rectangle. ½ inch that way, ½ inch that way. Working off midpoints. So what the X location is asking for is, alright, what's my midpoint on this shape? So X location, where is the center based off the back of the part of the machine?
Right in the center of the
Right
space,
center of
the
the
center of the
yeah.
slot.
So we'll dimension right over here, grab this. But here's where it adds a layer of confusion, because on these machines, traditionally for years and years, we only had a top drill, a bottom drill, and a front drill. Not until these machines came around did we start having back drills. And the programmer said, hey, in Glacier Studio and Partner Pack, for so long we've created all these fabs for machines that only had front, bottom, and back, and bottom and top, no back. But when the backs came around, they're saying, hey, instead of going into all this data and spending, a year, 2 years, going to every part and changing it to, okay, if it's a back drill, this is what you're using to fabricate that. Instead, what the machine's gonna understand is you're still sending the data out as if you had a front drill, but once it arrives, this data gets to the machine, you can open up the job on your side. It's recognized as, hey, I don't have a front drill, so I'm gonna flip all the data for a back drill. So it does all the math for you, and it understands to use a back drill. So they thought that was an easier way than having to go through all this data and adding back drill data per part, per fab. So that being the case, we have to dimension as if we had a machine with a front drill. So we're dimensioning from this back leg to where the drill is going to strike versus the layout of how the machine's going to take it, the orientation when you load it.
Right.
So don't ever think in terms of how Vincent's loading the material. It's going to be from if we had a front drill, which if we had a front drill, this is going to be sitting up against the back fence, and the front drill is doing the work. So if I'm dimensioning from 0 point, which is the back of the part, to where my center of the cutout is going to be, it's going to be right there in that midpoint. Now, I don't like the whole fractions. I need to adjust my tolerance. So let me go to my annotate, my dimensions, modify, architectural over to decimal, and then I just want 3 or 4 decimal points is good. I'll go to 4. Close. Let me dimension that one more time. So from here to the midpoint. That's what I'm looking for. Does that make sense so far, everything, why I've done that?
Mm-hmm.
If it doesn't, just let me know and I'll find a better way to explain it, but.
Makes sense.
Okay. So that's going to be my X location. That's the center point. And then eventually, once I give it that 11/16 that we told it to be, the length of that slot, it's going to know off this midpoint, I'm moving half of that distance in that direction, half of that way. Yeah. So that's my X, 4.3155. 4.3155. Y location. So Y location is, again, down the length of the material. Now, if I specify a Y location, The problem is you're gonna want several weep holes down that pan, depending on the elevation, right, off the ends inside the jams. And then if there's intermediates,
holes.
you want it to work out those intermediates,
Mm-hmm.
whether you want it left and right side, or if you want them at quarter points, however you guys do it. So instead of specifying a Y location, because if we did, we could tell, okay, I want one at 3.5 inches in. And then what you'd end up doing is having to do all the math on your own, and then create all these lines.
Under.
And then
Right.
still, it's only specific to that one piece of pan. If you make another opening, even in the same job, then you're gonna have to do it again. So instead, what we're gonna do is make it easier. Let's do 1,000 here. And what that's gonna tell us software is, hey, now we're gonna rely on formulas. And the formulas are gonna dictate, okay, off the ends of the pan, how far do you want them in? And then if there's intermediates, it'll do the math and say, okay, off the center line of that intermediate, how far off do you wanna be left and right? Or do you wanna work out quarter points inside those delos, or, and that now from here on out, it'll do all the math for you depending on whatever elevation.
Automatically.
Yep, you just, and it's
So-
on this part.
Just
So just put 1,000 and
Yeah.
that's it?
This is the first part of the formula.
Okay.
The second part's gonna be specifying if you wanna do quarter points,
Okay.
if you wanna work off the intermediate, left and right side of those intermediates.
Okay.
Those are the two typical ones I see with Conair.
I thought it would just do the Conair,
Standard.
standards, yeah,
Yeah,
like, just enter the standard or.
sure. I'll look at it, cause I've seen it changed. I don't know if they've gone to quarter points, but a lot
What
of
are we
shops.
doing right now? Quarter
The
points?
standard, whatever Conair's book says off of each,
It's like
center of
what
the
is it, center
shaft.
mullion or
I think
something?
it's 6 inches
Like,
left,
yeah.
so right.
Yeah, and I've seen that one a lot too. So we're now, just to tell the software, we're not done with this Y location, even after we're done with this line of data. But at least we put a placeholder for it to know, okay, hey, look out for a formula. Now the Z location is up and down. So where that's gonna hit. So we've gotta tell the top drill, where am I gonna be touching off on? So that's gonna be from the bottom of the part, which is 0, to where the drill bit first touches, which is gonna be up here, right? So I need this location. That's 1/2 inch. So then my Z location is 0.5. Now, with the X, Y, and Z, you've kind of triangulated where the starting point is. After that, now we give it a depth, okay? So, the depth over here, don't worry about RX and RY. So, this is a new feature on our machines. We have a new model that the drills, the top drill especially, or the back or the front, can move at angles now. And they can drill. There's some functionality with that as far as using it, but it's not a big deal that we don't have it. So right now, ignore these two. You don't use them. Depth. So here, we need to figure out how far we want to go down.
For the Z location, you just specify that we are gonna go.
Where the top drill's gonna first touch off on.
Okay, gotcha.
And then we give it a depth, how far you want to go in. That's what we're gonna do right now. So we can measure that. So I'm gonna measure from the base here. See, it looks like,
That angle.
yes, there's a little bit of a pitch here. So the thing is, if I dimension here,
You're not gonna catch the whole first.
yeah, I might wanna come down an extra 30-second or so. Looks like. Yeah. 10 thousandths, about a 64th. But I've noticed if I measure what I need here to here, just from experience, and then go an extra 30-second, it just barely scratches it up nice, so it allows that water
slow.
to give it a path actually to come out. And you still don't touch down here, because if you look over here, that's not right. it's close there. Let's add like 20 thousandths, because I don't want to get too deep where I'm starting to scratch this up. So I'm going to dimension this guy right here, top of this, to this base. I've got 0.4100, and I'm going to add 20 thousandths. So I'll make that 0.43. So on my depth, I'm gonna make mine, let's go 7/16 on our depth, pretty much what we're going to. And then the limit, the idea of that was originally that it could stop the operator from adjusting the limit too far or going too far into the part, because he has the ability to, if you go too shallow or too deep, he can change the depth on his end on the machine. So the idea of the limit originally was, okay, I'm gonna stop him at half an inch, that way he can't go past a half an inch on depth. But that's not really the case. He can change that to whatever he wants to. So that basically the idea is just make sure that this limit, whatever you type in, is just bigger than the depth. It doesn't function for what they intended it originally. The direction is going to be what drill we're going to use. So it's going to be either back, bottom, front, or top. So this is going to be a top drill. We'll program it. And the tool is going to be what milling bit. So if you want this slot to be 5/16 wide, gives it a nice opening when it mills through that, we're going to choose, so the D's are drill bits, the EMs are milling bits, and the CSDs are countersink drill bits. So we want to go to a milling bit to do this slot. So the EM11A is one that you have out there, but it's a 1/4 inch. We want to go a little bit bigger. So you can, what's that? The 5/16. Yep. EM14A. Yeah, the common ones that you guys are going to be using are the EM11s, which are the 1/4, and the EM14s, which are the 5/16. Alright, and then, now if you're countersinking, like on those sill pans too, are you guys ever wanting to put the anchor holes on the sill pan, or do you leave it for the field?
We put them on here.
You already do that here?
Yeah.
Okay. If you want that to be done on the machine, that can be done too. And that's where you get into this countersink cell right here. So if I did choose a countersink operation, like over here, CTSK, I would choose a countersink bit, like a CSD. And then what I'm relying off of is not this depth anymore. I have to put a depth in there so it works, so it can be anything. But what it really relies off is this countersink. And what it's asking for is when you get the screw, you get a caliper or a micrometer, and you measure the outside of that flathead screw. And then you type in that countersink diameter. And the machine figures out how deep to go to produce that countersink diameter. So whatever the hardware is, measure with the caliper, but to get it pretty close, add 10 thousandths on top of that. So 10 thousandths is 0.010. So add that to whatever you measure, and then you're gonna get really close to what you want. If you still need to play with it a little bit more or less, you can dial that in until you get it nice and flush, or however you like it. Yeah, that'll get you close. Maybe not perfect, but.
And how would both of those be done on the Rhino? Would it require 2 pass-throughs of one cut, or would you change the top mid
So
cut?
that's a new issue, because now it would be a top drill with both. And if we're doing weak holes this way, then we can't countersink.
Can't countersink.
But we can still put the hole, 5/16 hole, since that's where we're milling out. Because usually that's all we
Yeah,
use, is
we
1/4
can
inch
drill it, and
screw.
you guys can go later.
Yeah, we can have the field guys put a
That's
counter
easy.
sheet, you know.
5/16 is not too big.
Nah, for a 1/4 inch screw,
Yeah.
you know, and they only have to tap it once for the countersink in the field.
Yeah. Yeah, so
So you can,
That's
should
not,
be able to
you
use
can
the
still,
same
yeah,
drill.
do it by hand, that part. Yeah, we can still drill it out.
Okay.
Do you have like a catalog for the tools so we can get more familiar with the sizes or something we can use?
Yeah.
They're all into Michael.
Yeah, different bits.
Yeah. They're in.
Yeah, I will
Can
show you.
I get a copy of that? Because I had that one drawer full of them, I don't know.
I mean, I can give you the website, you can go.
Okay.
Yeah.
So it's over here in the
You're the one that
micro.
ordered all the bits, right?
So at themicrogroup.com, we go over to equipment and support, and then to knowledge base. So here's a lot of the manuals. So a lot of what we go over today, or in here specifically, is going to be found in Studio Software. And the Rhino side of things, I don't know if you have a little booklet out there.
Not sure.
Probably not.
Yeah, probably not.
But if it's not there, it's the Rhino reference guide. And on this is where you're gonna want to pull up that sheet for, this goes over like basic calibration, things that, different parts of the menu, IO testing that we were in today.
Right.
But on page 46, yep. Here's a page with all the parameters.
Yeah, that's what we.
Don't default to the RPMs though, because yours are the upgraded spindles, so the RPMs are a little bit different for the bits. But as far as lengths, even the quantity, if you see it on the far left, those are the ones that you have out there on the machine. The ones that don't have anything next to it, you don't have. You can order them, but you just don't have them. Has diameter
What that you selected the.
EM11 or 14.
Okay, so we do have. Yeah, 14.
Right there. Okay, so we go back here. I'm gonna switch back over to a slot because we're not countersinking. So if we're not countersinking, leave it blank. You don't even have to put a 0 if you don't want to. Now the width and height, like I explained earlier, if it's a slot, you're gonna do either or. You don't do both. Only time you guys do both is if it's a rectangle, and then you're creating a shape. Like if you were to do those notches, like on a mullion, a kernel mullion at the head of the sill, and you have to do those rollovers, those rectangular notches, you choose rectangle. Whereas over here, we're just doing one motion versus shape. So we're choosing slot. Now here's something you want to maybe write down or remember. If you're programming to figure out if you're doing the width or height, width is always down the Y location. So no matter what drill you're using, top, bottom, or back, they all move down the length when you're choosing width. So if the slot's going that direction, it's always in the width. Whereas the height can get a little confusing because for the top and bottom, height is across the mullion, not down the mullion. But if you're using a back drill, it's up and down. So the consistent way to think of it is, if it's width is always down the Y, no matter what drill you're using. That makes sense, yeah. Okay. But that would be a good indicator for you guys if you're programming in. Width is always down the Y location, and Y location is always down material. All right, so if we look back at I'll ask you guys, is this notch going to be down the width or the height?
So be down the width?
No.
No, the height, I'm sorry.
Yeah, width would be if we had it down that way, or shooting down that way, down the stick, versus across the part is going to be the height.
Gotcha.
It's confusing because you would think the
Yeah.
opposite is the height of the part and everything, but that's how they set it up. So over here on the height, we're not doing width, leave it blank. We're doing the 11/16. Diameter, we're leaving blank. Diameter, you only put in something if we're doing a circle. So if you're milling with this milling bit and creating a circle, then you give it the ultimate diameter. Say it was supposed to be 1.25 inches. That's how you do Metal fab type. This is important. You have to label what kind of prep this is, because eventually we're going to use a formula, and there's columns for where this corresponds to. So end center, just to make it easy, the two that you're going to use is end center, which are reserved for like anchor holes or notches, and then weep holes are for weep holes. So because this is a weep, we select the metal fab type weep. And then custom fab is super important, but you see how it's blacked out right now? It's not really checked. The Michael thought it was a good idea that if they made it blacked out, it would kind of show up to the person programming that, hey, it hasn't been checked. But it kind of seems like it's been checked.
Yeah.
But until you actually check that box, it's not checked. And why this part is important is because when the Michael rolls out an update, they do it every, I don't know, 2 months, 3 months. If you don't check that, your data just gets washed away with a new update. So that 037 part is going to carry whatever they tell it on their new update, and your data is not going to get saved. Whereas checking it's going to lock it in, no matter how many updates come through. So it's very important to check that off if you want that data to stay there. Bottom Z location, you're never going to use. And then function, for now, don't want to confuse you too much, so we're not going to use it. Very seldom will you use it. How do you guys feel so far? Pretty good?
Yeah.
Alright, so let me explain this part, the function. We're not going to use it for this part, but say like on a perimeter pressure bar, because you've got the same part number at the jams and the head and the sill, there's a spot to tell it, okay, what part number I want to use at the head pressure plate versus the sill pressure plate on that primary framing. But there's no way if I program the part, say if because the way you orientate the perimeter pressure bar in there, the weep hole is going to be in a different location on that leg. On the head, the weep hole is typically closer to that leg, and on the sill, because the way it snaps in to allow water out, the weep hole is further away from the leg. Now, the only way to differentiate where you want those fabs to show up on those parts, because they have the same part number, is to give it a function. So you write the fab data out with the correct X location for a head, and then you specify, okay, this is when I'm using this for the head. And then I create another line with the different X location for the sill, and then specify this line of data for the sill. Otherwise, there's no way of saying or understanding, hey, this fab has to go on this part at this time, because it's got the same part number all the way around. But really, that's the only situation you're going to use that.
Just with the pressure bar.
Perimeter.
Perimeter.
Perimeter, yes. Okay. Let's see.
You saw it on circle by the way.
So we go to slot. Bottom Z location. Don't have to worry about that ever. Function, rarely. Steps. Now, the steps are, if I'm going through this and trying to eat it all up at once, might get a little bit loud or a little bit hard on the milling bit, especially over time, kind of wearing that bit out. So instead, I gave it a depth to go all the way through. If I give it steps, say I type 2 steps, it'll divide that function into 2 steps. It'll do half of that, 7/16 or whatever I had it to go in half, do the first half, and then go down and do the second half. A lot less chatter, a lot less noise, a lot nicer on your bits.
Gotcha.
So I'd recommend that, and if you think, hey, we can try one, go for it. But we can walk first, and then if you want to start running, change to one. See how it's going.
Steps you put everywhere.
Yeah, for this. And then when you get into like things like if you start fabricating your door framing and you start doing like your transom header or your transoms and you're doing the pocket cutout and you have to melt that stop or the blade stop, it was a 1/2 inch blade stop, and if you're going to with that milling bit A lot of times it'll snap through that, so you can go through that half or in thirds, however you want to do it. So. But for most things, like even like when I'm doing the rollover cutouts on the mullions, I can do it in one shot. It's just because we're typically going through what, 1/8 inch material.
Yeah.
It's fine. But over here, we're going through almost half
Yeah,
inch.
even notches the head and seals for the curtain wash.
What's that?
It notches the head and seals for the curtain wash.
If we
I'll run
program
it.
it, we can. Yeah.
I'm gonna play back.
Alright, we're almost there.
Do
So,
it all of it.
Very exciting.
yeah, so steps we're gonna do 2.
Yeah, I'm like, shit, this is good.
And then pocket, you're never really gonna use, don't worry about that. Less to worry about. And then group number priority, if you had a robot, you'd worry about this maybe a little bit, but you're not gonna use it at all. So, whatever I filled out here, plus function sometimes, are things you might use. So this line so far is pretty complete. The only thing, if you remember this Y location, that's not fully complete. Right now it's kind of waiting for a formula. So let me show you how to do that. And then this week we'll be done. So we're gonna hit OK. I'm gonna hit save. Now the primary fab is saved on the part, but I need to go to the metal group and give it a formula. Now the thing is, if I go to this system, if there's multiple systems using that part number, I have to give it that formula that corresponds with that part number. So the cell channel, I have to give it the corresponding part number, or the formula on that metal group. And the reason they still force you to put the formulas on that metal group is because a lot of times companies use this page for however the architect specs out the job, and they're doing anchor holes, and maybe those anchors are spaced out differently per job.
Per engineering.
Well, then you can't just rely on one set way of doing your anchor holes. Weep holes stay pretty typical, but anchors change. So that's why even if you're using the same part number, same jam number, same cell channel, if you change part numbers and you're saying, hey, how come I thought we put the weep holes on that cell channel? It's because probably, 100%, you didn't go into your new metal group if you're not using the CGS one. You didn't add the formula at the end in here. So it's missing what to tie to. So it has no instruction, so it's not going to spit it out.
Because the 1000 just tells it to look here for the one.
And you never,
And you're
give it.
plugged in.
Mhm.
So we go to week.
So let's do that last step. So sill channel, I'm going to click on that guy. I'm going to move my way over. If you look at the sill channel, it's got an assembly too. And you can see what's tied into it. It's the actual member plus this part number, which is the weather, or the rubber, the vinyl. So that's really just for your takeoff, so you get a more accurate estimate when you're doing that, when you're ordering material. But otherwise for us, it's not going to matter. I'm going to move my way over with my arrows. Now as I do that, I can see that, you see this column over here, and this column over here. This is the end fab instant and center fab instant. These are reserved for anchor holes or notches, anything like that, or clearance holes if you have to make those. The column 3 and 4, you can see as I move down, I lost my place. They're reserved for weep holes, so weep end, weep center. Now there's 2 categories within each one. So the weep end,
Sorry, you said, end fab and center fab are for anchor holes?
yeah, these first 2 columns are for anchor holes, notches, clearance holes, anything special you might want to add to a part like that requires a formula. And then column 3 and 4, you'll see at the top it's labeled weep center, weep end. Now what does weep end and weep center mean? Weep end is, there's a category of formula to work directly off the ends of the part only. So like when you're working off like cover, you're not working off center formulas, really. It's just off the ends of the stick. It's cut to, well, practically deal a little undersized, but you're working off the ends. Same with the pressure bar, if it's cut between the verticals. The sill pan is a different situation because you still need the end formula, because you're working off the jams basically, or off the very ends.
Mm-hmm.
And then if you have several intermediate verticals, then you need the last column, which is the center fab formulas. And there you can dictate if you want it quarter points, if you want center of DLO, if you want it left and right side of each intermediate at what distance.
Mm-hmm.
So I guess, what do you guys want to work off? Off center of
So I would do
intermediate?
center
Left or
and
right?
6-6.
Okay, so that'll work off the intermediates, but we still need the end formula
Yeah,
to work off
which
the
would
jams.
the center down 3 inches, I would say.
Center.
No.
Off the center of the jam, 3 inches in? Or
No.
off the jam? How
It
many
would
inches
be
in?
DLO 3 inches.
Okay, perfect. Alright, so how that's gonna work for us is, there's a, probably because you haven't used it, there's another shortcut.
Okay.
There's F10, and this is the formula builder. So this one's gonna help you, so you don't have to remember all these formulas. So starting off, it looks like a lot. We're not gonna even use these down here, so don't worry. It's gonna be this weep end and the weep center. So start off by selecting the function, what kind of part it is. Is it a back member, base and pressure plate? It's a sill and head channel, right? So I select that, pretty easy. And I'm working with the end weep end formulas. So 99.9% of the time, it's just gonna be the L equals. I don't really fall into a situation where I'm using these. So L equals means off the very ends of the part. So if the member is 2 inches, then I have to account for the 2 inches plus how far I wanna be off the end.
Gotcha.
So you said 3 inches off the jam,
Yeah,
so total 5.
yes.
And then if you want to get really picky, because the sill channel extends past the frame, 1/8 and 1/8, you can say 5 and 1/8. And then there'll be a true 3 inches off the jam.
Gotcha.
If that makes sense. And it'll put it on both sides.
Right.
It'll mirror.
Right.
Okay?
Pretty
So that's
much
what
like
5
typical.
Yep, 5 and 1/8.
59.5, so wherever they were, 57.5 should be it.
So we copy the clipboard, close it out,
Done.
and then if you want to double click and right click and paste, or if you know your commands, Control V, paste that in there. But you need this checked off. Even if you do all the work here and you write the numbers and you don't check it off, they won't send it to the machine. So you gotta check this weep end with the weep end.
And so that just gives you the formula, and then you have to copy and paste it in here?
Yeah, it just helps you
Okay.
build it.
Okay, perfect, I was just curious.
Yeah. And then we have to do the centers. So we're gonna check off the weep center, and then move over here, F10. And then I'll go over to this, sill channel. And then now we're gonna work with the center, weep centers. So they're all like cell based, so if you're familiar with Excel, if you're not, I'll explain it. So they're all like condition
Same
based.
thing, F10, right?
F10. So they're all built off conditions. So if length is greater than or less than whatever condition you set, then I'll do this formula. So the reason they built conditions like this is like, okay, if you're doing, say you're doing quarter points on your anchor holes, and then you have a situation where, okay, if the stick is, or the opening, the DLO is larger than 48 inches, hey, shoot one at center of DLO, add another one, anchor hole. That's where you can set conditions and say, okay, if length is greater than 48, then you can, which would be this one right here, 48 inches, then Y equals DLO, and now shoot at center of DLO only. So that's what that one is. This one up here is like, if length is greater than or less than whatever number you put, then Y equals the length of the stick divided by 2 on center. So it's just saying dead center of the stick. It's very similar to DLO. The next one below that is going to be if length is greater than this number, then Y equals blank on center. So that means, okay, I want it every 12 inches on center. Every 12 inches, 12 inches, 12 inches. If length is greater than this number, then Y equals center line. So that's going to be center line of the intermediate vertical plus this number. So say your member is 2 inches. So 1 inch would take you to the edge of the vertical, and then how far you want to be off the edge. So you said
3 inches usually.
3 inches off the jam. So that would give you 4, right? That makes sense? 4 to get off the center to the edge, then 3 more. And now what that 4 would do is would do 3 inches off this side of the vertical and 3 inches on this side. So it would mirror. And that's the one you guys think you'll use? We have to give it a condition right here. So when do you want this formula to apply? What's gonna happen is if you think about it, if the side light, the smallest side light you have is 8 inches, and it's 4 inches, you're gonna have 4 and 4 off the end. It's gonna be a hole right overlapping each other, which is not gonna hurt anything. But what do you think is the smallest side light you guys will run through that machine?
Our typical clear stories, Daniel, what are they? 5 foot?
No,
Smallest side
Yeah,
light.
yeah,
I would
yeah.
say, I would say what you just said,
12
maybe somewhere around
Yeah, I
there.
would say 8 to 10.
8 to
12.
yeah.
It wouldn't
Yeah,
affect
probably
the
good.
stories, you have no.
Okay.
Cause they do have
Two
like
in.
a minimum glass size they can make.
No,
Yeah, I would think
so
12 probably.
I didn't really go on.
What do you think, Jimmy?
Oh, he's doing
I had side like
Yeah.
small side lights that are 5 inches.
Yeah, that's why, yeah.
See, I would say like 6 inches. 5, 6 inches.
Okay. That's fine.
So on there, we select what?
So if your smallest is 6, then you might want to go like 5 or 4.
Mm.
Something smaller, because if you have a side light that's gonna be 6 inches down the road, and I choose 10, you won't get those.
Yeah, you're gonna have to manually do it when those come out. But if, let's say you put 5 there, and then you get one that's 6 inches, what is it gonna do for those 2 4 inches? Are they gonna end up
Yeah, it'll move
across
across
each other? Okay, so you'll
Yeah.
still have 2, and they just won't actually be,
It won't
they will be 4, but they'll actually end up crossing, so it'll be more like,
Yeah, they'll go past each other.
I understand, okay.
So,
Yeah,
yeah,
which
like
would
you were
cause
saying,
issues.
I give it a small number, that way it accounts for any small side lights.
correct. So you put 5, right?
Yeah.
And then
Then you just copy the clipboard, and before I jump out of here, let me explain the rest of them, and then I'll paste this. So over here, the next one over is gonna be that DLO, center of DLO one. So you set your condition, say it's 5 inches again, anything bigger than 5 inches will get a weed pull at the center of DLO.
Cool.
Next one down below is gonna be your quarter points. So then Y equals DLO divided by 4. It does that the first quarter and the third quarter. And then after say you were to create this, you can copy this and paste it. You can modify this, not in here, but once you paste it, and you can type a 3 in there instead, or a 5. You can do 5th points, or 6th points, or 3rd points.
that's the one that we need right now, though, right?
It's this one, the center line one,
Something like.
which works off the center of the vertical, intermediate verticals, and it works left and right. You got a picture of that, or you want me to-
No, I'm trying to write it down. Yeah, then Y equals here.
Would you be able to, so like if we did that, how we just had it set up, where the smallest one here is 5 and it would do it 4 inches from center line, would you be able to set a different rule where now, let's say you had this highlight that was, or let's say you set it at 10, so that you end up with just 2 inches between your 2 holes when it actually sets it. Let's say you wanted it to stop there, and if it was smaller than that, and the holes were gonna start crossing, you wanted it to do a different layout, is there a way to put 2 different rules on it?
100%, you can do
Okay.
as many as you want.
Okay,
But it takes it literally. So if you think of it this way, if I do greater than 10 inches, it literally thinks like even if you have a DLO that's 10 inches, it's
yeah, it's
saying
gonna, I
until it's
understand.
10.00001 or something,
Mm-hmm,
that 10 inch won't get it.
I understand.
So you can put
9.75 if you wanted it to do, yeah, if you
whatever it
wanted it to do 10. Understood, okay.
and then below that you can say, okay, if it's less than this number,
Mhm.
9.98 or something, then those will get however you want to change
So
them.
you write it just like an Excel formula, so
Yeah.
after you do that, okay.
And then how you would, I'll show you how to apply multiple formulas.
Yeah, just if then, if those, and all the rest, yeah, I understand.
That's the quarter points, and then the last 2 are kind of atypical. If length is greater than or less than whatever arbitrary number you pick here, then Y equals however many inches on center plus an offset of whatever half inch or whatever you want to do. Same with this one. If length is greater than or less than this number, then Y equals the center of DLO plus an offset. I don't really see you guys using that. I've never used it, but it's in there. Again, the typical ones for weep holes I see is quarter points, or the center line one that we had chosen. Alright, so I'm gonna close this, I'm gonna go over here, I'm gonna do Control V to paste. Now say I need to do another formula, oops, I don't want that one. I'll go back and recreate the one we want, but if there's more formulas in this one, and I need to apply it here, just put a comma, space, and then paste the next one in. And you can apply 10 if you want, whatever.
Is that a comma?
Yeah, comma, space, paste. So let me go back to F10. Let's create the one that we just wanted. Center line, 5 inches, 5 and 8.
Mm-hmm.
Copy, paste. There we go. And now I can go over here, hit OK. I can save this. And now if I go to an elevation that I've built, this one got it. This is 451T. So what I'm gonna do is I'm gonna import this into metal fabrication. I don't know if some of you are estimators or project managers or a mix, but if you're not familiar, metal fabrication is the post-processing software. Basically just a fancy name for like a translator, because this software works in like Java and software language, and the machine out there works on a code called G code. So for it to understand all this stuff that you program from the office to there, it needs like a translator. And that's what this metal fabrication is, this screen right here. So when I import the project I want, say it's this Conair test, hit OK. What it's doing is it's converting it over to G code, even though you don't know that, or can't see it. And then you can output and send that to the machine if you're linked up. So what we want to do is if I go to preview frames, don't worry about what's going on here. Oh, actually, what's going on here is the software doesn't recognize how to attach these new, but it's because I put it on a storefront frame anyways, but don't worry about the red X's for now. We want to look at the sill channel. So the sill channel is the 1SC over here. So if I go over here, go down to my list, look for the 1SC, it's this guy. If I click on the box over here, it highlights the whole row, so I don't have to, use my cursor to not lose my place. And then to look at the fabs, I open up this add operations box, this blue box right here. And it doesn't have it, so let's see why it doesn't have it. Oh, it doesn't have it because that project was never using our metal group that we made. So let me go in here, let me change up the metal group. I'm gonna go to this guy over here, the AGS. It's gonna swap some parts out, that's okay. Save it. Close it out. Metal
Do you have
fabrication.
to then recap it or not?
No.
Because you're gonna import the project again.
Oh, to take changes?
Yeah.
No, yeah, you can do it that way, or you can just do it this way.
Okay.
But you do have to re-import the project. Which is a good point. I'm sure you guys are all accustomed to it, but this job, even if I change things, like I just changed the system in there, it doesn't automatically take in the changes that I made in that metal group or in that job. You always have to re-import to bring in the newest version of that job. Okay, so the 1SC right over here. Click on this. And I can see now I'm using the top drill, I'm slotting. Here's all the EM14 operations. And if I want to get a better look, I can click on detailed view over here. And if it's a little too dark, I can lighten it up, lighten the part up with this transparency bar. I can click over here and move it left and right. I can rotate, move the part around. I can zoom in with the wheel. Now the rendering isn't always perfect. Like over here, you can see they're completely off. But if I look at what will not lie to you is the hard data. So if I look at the X location, it's at 4.3155. I can look back at my CAD details and feel rest and assured that okay, the data is good, even though the rendering is like, hey, what is this tab right here? That's completely off the part, but it's actually doing it. And if I hit detail view again, dimension, it tells me off the end of the stick where they're going to be at. And if I did the math, I could say, okay, what's 144 1/4 minus 139 1/8, and you get that 5 1/8 off that end as well.
Yeah, and you can tell it's the distance between them, they're all 10 1/4 from each other.
And you can tell there's intermediates right here, here, left and right side. So it gives you all the math here. If you have to change out a Y location as a one-off, I'd suggest doing it in the formula or doing it as a wholesale change in the metal group. But say it needs to change on this specific part, or say it's a small part, like you're looking at a 6-inch part and you don't like where the weeps end up, you can always change it right over here on the Y location. So say I want to change this 5 1/8 to 10 inches in, and then I can hit draw fabs, and now I change that weep hole to 10 inches in. Okay, and then all that's left to do is to send that to the machine and how they can do it. So that's the weep hole. Do we have time to do the anchor hole before lunch? You guys good with that, or is it lunchtime?
It's not 11 yet.
Looks so,
Yeah, I was about to say that for me.
I was looking at that.